Thank you everybody for coming to my session. My name is Andriy Shapochka, and it's hard to pronounce. Yeah, I know. I'm working for a large Ukrainian software development consulting company called SATURN. And today I'm going to share our field experience in applying trade-off and cost-benefit analysis techniques to assess software project technical debt. Something that we started to do recently. So here's our agenda for next 15 minutes. First, we'll talk about the challenge that our client faced and actually presented us with. And next, we'll have a detailed look into the assessment we conducted to assess his product and actually kind of address this challenge. And finally, we'll look at the results of our cost-benefit analysis that was performed as part of this assessment. And in case you might have any questions about our method, you are welcome to reach me after the session, and offline, always open. So, first of all, let's review the context of the assessment. So, our client was a Western company that specialized in building large-scale network security solutions. And one of their solutions is presented here on the high level. So they had security subsystem, and which actually talked to the database, to the configuration database, and another subsystem called configuration web portal. And actually, the target of our assessment was that part, configuration portal. And it is a Java web application structured as a layered application and based on the standard stack that you can find in Java, like Spring MVC, Struts, Hibernate. And I would say it is mid-sized, like 55,000 lines of code. So, okay, there were a few important business level concerns that our client listed to us during initial round of communication. First of all, they saw that the development team production fell down over the last couple of years, and they measured their productivity in basically in completed user stories and fixed bugs, stuff like that. They used their velocity. Also, they felt that it required considerable effort from the team to reach, production quality to make the next set of features to the production. And also, there was a general perception that the quality of features, quality of the bug fixes, and quality of the code base kind of was quite low by their standard. And our challenge was to find actual technical root causes of those business problems, and to provide a set of recommendations and in the technical area mainly, but also in the process area, how to fix them within the constraints that we had, like budgeting constraints and also time constraints. That we could only propose recommendations that could be addressed within 1 year of development, let's say. So let's now review our approach to the assessment. We based our assessment on the ATAM and CBAM methodologies developed by Software Engineering Institute. And as a first step, we decided to run a quality attribute workshop with emphasis on the quality attributes that, by our experience, typically affect teams' productivity and quality of the software they produce. And next, we decided to concentrate on the quality attribute scenarios which were which basically would have high priority, right? And so we could expect to achieve to get a higher benefit by addressing them from our recommendations. And also we decided to apply both qualitative and quantitative code analysis to kind of identify hotspots, risk areas in the code and in the portal logical structure. And then, based on all this aggregated information, we would actually conduct the cost-benefit analysis to understand whether our recommended approach, our set of recommendations, really makes sense from the business standpoint. So we ran the quality attribute workshop using mini QAW technique, which was actually presented on one of the sessions last year on SATURN 14. And as a result, we basically collected a list of pretty standard quality attribute scenarios, like in the form that is presented here. So here you can see actually the list of the prioritized scenarios, and we categorized them by the primary quality attribute that they addressed: modifiability, testability, and reusability. So if you look at those, it is kind of obvious that all of them are quite tightly connected to the productivity and quality concerns that management had. And on the other hand, again, if you look at them, they kind of hint that there is a probably large amount of technical debt accumulated somewhere within the code base that prevents the team from achieving, the desired response measure value. And next, we assigned importance and penalty values to the scenarios. Penalty here means that what penalty would it have for us if we did not address this scenario in our recommendations and in implementation then. And besides, we also put worst, current, desired, and best case response measure values and mapped them to the so-called benefit values, unitless benefit values from 0 to 100. Those were basically perceived benefits from the point of view of the stakeholders. And those benefit values would later be used in the cost-benefit analysis. Okay, so next step, we did the architecture and code walkthrough with the development team. And by the time of the detailed quantitative analysis, we already understood that primary root of the situation was, like I said before, the amount of technical debt. And we also understood by retrospecting the development process that team did not have enough time and did not have proper development process in place to pay off technical debt gradually. So it kind of accumulated and burdened new development and maintenance. Okay, so we to find out more about the areas of technical debt, we used a few tools like Structure 101 and of course SonarCube and IntelliJ IDEA to integrated tools to find problematic areas. But also we just went through a set of code reviews. Okay, here we can see an example of the output from the Structure 101 produced. It basically measures excessive complexity and shows fat packages, places where the code is tangled on the design level, and so on. Also, one more example, you could remember from the slide with the system view that there were Spring, MVC, and struts living alongside, and basically two different web frameworks living side by side are also major suspects, right? So as a result of our analysis, we worked out a set of recommendations, and here it is shown on the very high level, but of course the detailed report included and elaborated on the particular parts of codes and particular refactoring patterns that we should use, and so on. And eventually we built a roadmap, refactoring roadmap, and most important, estimates how much effort it would take to apply our recommendations. And those effort estimates, they formed the base for the cost calculation, for the cost-benefit analysis. Here's the formulas that we used to calculate value for cost, benefit values for to use within our cost-benefit analysis. Here, drivers mean quality attribute scenarios, and decisions actually mean the set of recommendations that we formed. And benefits, costs, risks, and penalties are unitless, normalized values from 0 to 100. Those formulas are actually based on the formulas from CBAM method that again, Software Engineering Institute developed. So here's the step of our CBAM approach. I would not go in detail through them, but you are welcome to look through them when the presentation is available on the site. Here's something called decision trade-off matrix. This matrix basically maps recommended decisions to the high importance drivers and helps us calculate the resultant benefits of those decisions, so how they actually affect those critical drivers. Let's see, here's this design trade-off matrix for our particular case. Here rows represent our highest importance quality attribute scenarios, and columns represent current approach the team uses and to develop the record, and the recommended approach, including a set of recommendation. And totals presents the total benefit. And we can see that, of course, the recommended approach, it brings much more benefits to the table eventually, because intuitively, because as a result of refactoring, we will get much better code Okay, and as a last step, we actually calculate values for cost. So you can see here that while benefit values are considerably higher for recommended approaches, the value for cost is not so high because of cost of the recommended approach also includes additional effort to refactor, which cannot be paid back within the single year. And so still it is higher, and the result, when we presented our results of the analysis to the management, it was decided based on those numbers as well, the other considerations, to go forward with this refactoring effort and to accomplish that refactoring within 1 year. There are a few answers to typical practical questions that you might have applying this method, and in case you have any further questions, please don't hesitate to reach to me. My email also is on the next slide, and thank you for your attention.
So we have time for one question. Is there a question?
Does your organization have enforced coding standards?
Excuse me?
Does your organization have enforced coding standards?
Oh yeah, of course, and we have actually SATURN and to kind of monitor it consistently during the continuous integration, and also local tools integrated with Maven and with IntelliJ IDEA to monitor coding conventions, and of course there are some design standards that should be enforced, and also it was part of the recommendation to actually explicitly codify those design conventions like layering, using frameworks, etc.